Good morning, class. Welcome to the online classes of physics for class 11th. We have started the new chapter in the last session, that is force and the laws of motion, in which we have seen what the force is and we have discussed about the three laws of the motion. And we have talked what are the statements for the three laws of the motion. We have said that what is the force? Force is an external effort that is exerted on the object, which it can change its state of rest or the state of motion. It can change its velocity, it can change its direction, size and shape. So any external effort done by the external agent is on the body is said to be the force. And we have talked the force are of the two types, that is contact and the non-contact force. And we have even talked about the balanced and the non-balanced force. Balanced, what it was, that when the resultant force acting on a body is zero, that it is said to be balanced, because if a body is in the balanced condition, then the body will not move. So balanced force does not allow the body to move, it just changes the shape and the size of the body. And whereas the unbalanced force, the net force of the resultant force is not zero. Okay, there will be some value of the resultant and the net force. Now if there is an unbalanced force applied on any object, then the body will change its shape and the size along with the motion also. So the body will try to move in the unbalanced force, but in the balanced force the body does not move. Okay, so these were the two forces that acting on a body, that the balanced and the unbalanced force. Similarly, we have seen the three laws of the motion. We have talked about Aristotle, Galileo and the Newton's law of motion. What the Aristotle told, that whenever the body is to be moved or to be changed the state of rest or the motion, then the external force should be applied on the body. This was the Aristotle's theme. But after that he proved that wrong statement and given by the Galileo. And what Galileo told, that there should be some opposing forces also there on the object, due to which the body is moving, not only the force exerted by us, right? Because if we want to push a ball, then we are just pushing it, and we think that by pushing our force or by the force of our pushing only the body is moving. But not that is the reason, but there may be some other opposing forces also there acting on the body, and our force should be more than that, the value of the opposing force. So if our value is more, then the body will start moving rapidly. So we can say that the opposing force is always present in the direction of the opposite to that of the direction of our force. Okay, so the Galileo's theme was good, but after that Newton told that opposing force is also there and the external force is also there. But he told that whenever a body is at rest condition, then it tries to be in the rest, and whenever a body is in motion, it will continue its motion. This property is said to be the inertia. And he said that to change the state of rest or the motion, it will not change until or unless the external force is applied on it, right? Whenever the force is applied on it, it will change the state of rest or the motion. So he said that he given the quantity of force also. He told what is the inertia also. So this is a law of inertia, or it can be said as the first law of the motion, in which he told about the motion of an object, how the motion of an object influenced by the force. And what was the second law was, he told about the momentum. He described what the momentum is, and he told how the force on any body just depends on the momentum, right? He gave an expression for the second law of the motion, that force is directly proportional to the rate of the change of the momentum. So he described the force also, momentum also, as well as the relation between the force and the momentum. And what the momentum was, it was given that momentum is an impact of the force in any object, which is defined as the product of mass and the velocity. And we have seen that the momentum cannot be zero, right? Momentum cannot be zero of any moving body. But if it is zero, then we can say that the body is at the rest condition, because m into v, any one of the value will also be 0, then the momentum will be 0. So either m should be 0 or either v should be 0. But m cannot be 0, because mass of any body cannot be 0 at any condition. But the velocity can vary, right? Velocity can vary, it can be 0 at any condition, because if a body is at the rest, then the velocity is assumed to be 0. So if velocity is 0, then the momentum will also be 0, because v and m, they are in the product. So if v is 0, then 0 into m will be 0. So the momentum of the body at the rest condition will be 0, and whereas the moving body, the momentum always it will possess. Okay, and it depends on the mass and the velocity of the body. Okay, so we have seen that the second law of the motion just tells about the momentum, quantity of the force also. And from there he derived that force is equals to dp upon dt, as well as he derived that force is equals to mass into acceleration. So second law tells us about the mass and the acceleration of the body related to the force. And what was Newton's third law? One of the favorite statement for every students of this class, because third law gives us that every action has an equal and the opposite reaction. And everyone knows this statement because this is one of the favorite statement for everyone, right? Because if someone asks you what is the Newton's third law, it is easy to tell. First is also almost everyone know, but the second law sometimes we used to forget that what the second law is. So it is just that the every body's force depends on the change in the momentum with respect to the time, and he also derived force is equals to mass into acceleration. So this were the three laws and what the force is. So today we are going to see some more three topics in the class. This video may be somewhat lengthy, but try to understand the topics because we have to complete this chapter in 2 more days. Okay, so in 2 more sessions we have to complete this chapter, and after that we have to see 2 more chapters extra. So try to cover it faster. So here we are going to see a new topic in this session, that is conservation of the linear momentum. We are talking about the linear momentum. What does it mean? That whenever a body is in the motion or the body's motion is in the straight line, it is allowing to move in a straight line, then the momentum regarding this particle moving in a straight line is said to be the linear momentum. Because similarly we are going to see it in the rotational motion also. Okay, when we are talking about the rotational motion next chapter, then we will be seeing that the angular momentum will come. So here this is about the linear momentum, and I think this topic you have already went through in the last class 9th also, right? Class 9th also you may have read this chapter. So this topic is about the momentum itself, and now what the momentum is, it is the impact of the force on any body, right? Impact of the force on any body. It just tells us the quantity, that how the force is experienced by that body and how is it moving due to the force. This is just a quality or the measurement of the force. Okay, this is just a quality of measurement of the force on any body. So what is this conservation? If we are talking about the conservation or a conservation principle for any of the amount, any of the velocity like acceleration or about any of the vector quantities, then it means that whenever the addition sum up of or any after condition or the before condition, then the sum up of both the values should be equals to some magnitude. Maybe direction changes, but the magnitude should be of the same. Then we used to say that the value is conserved. Like if you conserve something for a future, then we are saying that the object is at the same time now you are keeping should be equal to that the object will be kept at the future. So both are in the same condition, so we can say that the both are conserved. Similarly momentum is also conserved. Now how the momentum will conserve? We can say that the situation before should be equal to that after the situation. The momentum should be equal in both the situation, before and the after situation. Now how the momentum will be told? Now just think of an example that whenever we used to drive a car or to drive any of the vehicles, we used to apply the brake and the object or that vehicle used to stop, right? And it stopped at instant, right? It just stop at any instant that we have just applied the brake and the object is stopped or a vehicle is stopped. Okay, now if we are to stop a train or stop a flight, can we easily stop like this? It will not stop at any instant. Why this happens? Because we know that the momentum of a body depends upon the mass as well as the velocity. It depends on both. So whether the velocity is increased or not, but the mass is a specific quantity of that object, and every object have its own mass. If we talk about a train and a car, if we just relate them both, whose mass is larger? That is the train. So train's mass is more, whether its velocity is increased or not, its momentum will be of large value, right? But we know that the train's velocity is also more. So both mass as well as the velocity both are of the larger value. So the value of the momentum will be also of greater value, right? So momentum is very great. So now if we have to stop this object or we have to make it on the rest position, we have to apply some force. We know that the body, to bring it into the rest condition or to make it into the motion, we have to apply the brakes or we have to apply the force, right? And brake is a kind of a force which is used to make a body to come to in the rest position. So to stop a body, we have to apply some brake, and these brakes tells us that it is an external force. So force is applied to change the rate of momentum. Now the body is moving. So it's, since we are taking an example of a train, okay, you can take an example of aeroplane also. If we are taking its mass and velocity, it's too large, so the external force should be also of too large. Now we have applied a force by using an engine, because the train's engine is there. If you're talking about a flight, then also the engine is using as a brake. Now you have just stopped the object. Now what it will be? Whether it is stopped at any instant? No, it will take time, so, right? Because it will take time, somewhat like seconds will be there to stop the object. Now what that driver used to do, that he used to apply the brake before 10 minutes. The station is going to come, then he will apply the brake before 10 minutes. And we used to see this because when we are sitting in the train, then we used to observe that whenever the station comes, before that itself the train used to be slowed down, right? So before 10 to 15 minutes he used just apply the brakes. What does it mean? That the momentum is already very large of that object or a train. Now if it has to be stopped, then the force is also of that much large value, but we cannot apply that much large value to a vehicle or any object. So we are applying the brake, but of a limited condition, right? So the object will take time. Now the force is applied, the body is allowed to be in the rest condition, but then also the train is moving, then also the train will be moving and it will stop at some time. Now what this thing which is applying on this body to move, this is the momentum. So momentum is there in the body, which is now also working on it after the applying the force and after applying the brakes, then also. So the body is in the rest condition, but then also there is some momentum preserved in the body which is allowing it to the now also to move. Similarly in the aeroplane also, the body used to, whenever it land, it just take time, right? It just take time to stop. So we can say that whenever a body is there, the momentum depends on its mass as well as the velocity. Now we are talking about the two objects, right? Because the conservation of momentum, then we have to take out the two situations. One is that before collision, and what is collision means? Collide of a two object means in a Hindi you can say it as takrana. Okay, any body, if they are colliding each other, then there is some mass and the velocity. Like if you are just going into somewhere in a vehicle and you are just colliding to someone else, like a small hitting with each other, and then what it happened, that if it is coming at a less velocity and you are moving with a high velocity, whenever you strike the other person or other vehicle, then what it happened, if you are at the high velocity, then that person will fall easily, right? You will not fall. The person with a less velocity will fall, because your momentum, that your vehicle carrying the momentum of that mass and the velocity of that vehicle will allow to give its momentum to that vehicle also. So the next one will fall. Similarly, when we used to drive a car and the other person is coming in a cycle, then what we used to do, any accident had happened, then we used to say that every mistake is due to that car itself, right? A person in the cycle is not to be allowed to done an accident. We always used to say that the car have done the accident, or the car have allowed the body to do the hit, right? So what it means, that the momentum of the car is high. So whatever the momentum of the car is, it will be added to that of the momentum to the cycle. So he will be pushed down, right? Because he will be pushed backward direction. Whenever the car hits a cycle, does it happen that the cycle will remain there and the car will move back? No. Because the momentum of the car is heavy and the mass of the car is heavy, velocity is greater. So the car will hit a cycle with the larger momentum and the cycle will go in the backward direction with the highest velocity. So the velocity of the cycle will be of the velocity of car. So the momentum of the car is now added to that of the momentum of the cycle. So now the cycle will move with its momentum of the first object. So this is what means, that the momentum of the car before collision will be equal to that of the momentum of the car after collision, because now the momentum is same. Let us consider that the car is moving with velocity 20 meter per second, and let the car be moving with 80 meter per second. Now what is before collision, what is the total sum of the momentum of both the vehicles? It is 100 meter per second, because one is moving with 20 and other one is moving with 80. So together they will be 100 meter per second. So after collision, now he just hit the car, the cycle will move backward with some velocity. And what is the velocity will be? Now also the momentum will be added to both. I am not talking about the mass now, okay? Momentum is there, so mass should be there, but to take an example, we are taking only the velocity. So now the momentum will be added to that of the cycle. So this 80 meter per second will less, and now it will become reduced to, let us consider that it will reduce to 50 meter per second. So now this 50 will add up to the cycle. So the remaining 30 meter per second will add to the cycle, then it will become 50. Together now also they are 100, because the cycle's momentum now it became 50 and the momentum of the car is also 50. So together they will be 100 meter per second. So before collision is also 100 meter per second, after the collision is it also 100 meter per second. So what we can say, that the momentum is conserved, that is before collision and after the collision. You may have read this topic in the class 9th also, but not so much deeply, because at that time the derivations were not taken under conclusion, because we don't know that what the derivation is telling about. But here you should know the derivation also. But for your term 1 paper, the only MCQs will come, so derivation is not required, but you should know how the formula is derived, because in the numericals we should understand that what is the derivation required for this question. Okay, so here you can see what is the conservation of momentum. If no external force acts on the system, the total momentum before collision is equal to that of the total momentum after collision. Okay, so there are the two types of collision, that is elastic and the inelastic collision. Both collisions will be there. If you think that whenever an object strikes the other object or a collide, when they collide with each other, they just move. After collision they will move together. No, they will be moving in the opposite direction. They will not move together, they will move in the opposite direction. So they will be moving separately. So this is said to be the collision in the elastic collision, because the conservation will be equal to that of the momentum after the collision itself. So conservation is equal. So now the body will be moving with different velocities in the different directions. But if we talk about the inelastic collision, what does it mean? That now the momentum will be added together. Like if we strike a ball, striker, you know the carom one. Sometimes when we strike the red coin, let us consider the red coin, then we have to take the help of the other coin also. And if you strike the white coin, then it will touch the red coin and it will together move into the hole. And sometimes it happens that when we touch a black coin, not necessary that it's white and a black, but whenever we touch the other coin to hit that red coin, what would happen, that it touches the red and it remains over there, and the red will move into the hole, the black will remain in the same position. But it's not necessary every time. Like I told you earlier, that the white coin will hit the red coin and they both together will go into the hole. So what we can say, this is the conservation of the momentum, like elastic and the inelastic. If they move together, then it is said to be inelastic, and if they move separately but with the same momentum, that is the conservation of momentum is there, then it is said to be the elastic collision. So this collision, you see this object is moving with some mass m1 and m2, both the masses will be m1 and m2, they are moving with velocities, that is initial u1 and u2, and together after collision will be moving in the different directions. They are moving separately, not in different opposite directions, but they are moving separately. Then also their mass will be m1 and m2, mass cannot be changed, but the velocities will be of the final, that is v1 and v2. This is said to be m1 u1 plus m2 u2 is equals to m1 v1 plus m2 v2. So this is the relation, that total linear momentum before collision is equals to total linear momentum after collision. So this is the conservation of the momentum. But in the elastic collision, they will, after collision they will move together. So what their value will be, that is they let us consider the body is at the stationary. This body is at the stationary conditions. The velocity of the momentum, velocity of the mass second body will be 0. So mass of second body is 0, and let us consider like a red coin is at the stationary position. So we are just moving this striker to strike that red coin. We are using the white coin. Let us consider that we are strike the white coin so that it will move and will strike the red one. So now the red is at the stationary and the white is in the motion. So motion of this white coin will be given as m1 and velocity will be given as u1. But the red coin is of mass m2, but it is not in the motion, so it is given as 0. So velocity is 0. Now when it strikes, they will move together. Okay, let us consider that they move together. So their both velocity will be together v. So together the velocity will be v, because what is the velocity of the white coin? The same, the velocity of red coin will be also same. So they both together the velocity will be v. So m1 and m2, their mass will be tied, like we are tying together the two masses, and the mass will be added up. Similarly, they are moving together, so the mass will add up. So it is given by m1 plus m2. So it what will be the formula for it? That before collision it will be m1 u1 plus m2 u2, and after collision it will be m1 v plus m2 v. So both are v. So together we can write it as m1 plus m2 v. This is the relation for the after collision. So these are the two collisions that tells us about the conservation of the momentum. Here you can see the figure also, that whenever a momentum before collision, the two objects are moving with some velocities u1 and u2, and after collision they are moving separately. So this is the elastic collision itself. Okay, so the derivation can be given as this, like since the body is attracting each other, like attacking each other and moving in the different directions, so here we can say that every action has an equal and opposite reaction. So it will allow the rule of the third law, that is Newton's third law will be what the rules tell us, that every action has an equal and Opposite reaction. What does it mean? That the force acting by the first body on the second object will be equal to that of the force applied by the second body on the first object, but both are in the different directions, so it will be F12 is equals to minus F21. I have told this earlier also. So both the forces will be of different, and now we know that the force is directly proportional to the momentum. So from there the relation comes, that is the total momentum before collision is equals to total momentum after collision. Here are some examples of the conservation of the momentum. That is, rocket works on the principle of conservation of momentum, and jet planes also works on the principle of conservation of momentum. Here the gases that are acquiring from the rocket will be of some momentum, and the body of that rocket which is moving upward will have some movement. So both the together the momentum should be in the conserve. So this is the principal working of the conservation of the momentum. And you can see another example for the conservation of principle of momentum. This is in the 9th class book also. You can see this, that the momentum of the bullet, whenever it moves or whenever the gun is fired, the momentum of that bullet will be equal to that of the momentum of the gun itself, right? So the velocity of the bullet will be equal to that of the recoil velocity of the gun. What this recoil velocity is, we know that whenever the coil is fired or the gun is fired, then the gun just jerks backward, right? The bullet imparts a momentum that is in the opposite direction. Since the bullet is moving in the forward direction, it will jerk back the body in the backward direction. So here it is opposing a force in the backward direction. So this is the recoil velocity. So we can say that the momentum of the gun will be equal to that of the momentum of the bullet itself. So here the velocity of the gun will be given as the recoil, because it is taking the velocity in the opposite direction to that of the bullet. So the numerical can be seen here, that the bullet of a mass 10 gram is fired from a gun of mass 6 kg. Okay, 10 grams it is the mass of the bullet. Gun's weight is 6 kg. Now it is moving at velocity 300 meter per second. Now the recoil velocity of gun will be, if you want to solve this, you can solve also, that the bullet of mass 10 grams, so M1, that is bullet of mass, is given as 10 gram. Now the velocity of the bullet is given by 300 meter per second, and we know that it should be equals to that of the mass of the gun and the velocity of the gun. So M2 will be given as 6 kg, but the velocity is not given. We have to find this recoil velocity, and we know that this is in the gram, so it will be divided by 1000. So 0.01 or 1 upon 100 into 300 meter per second. So it will be 3 meter per second. Now we know that this is 3 meter per second, and that's it is 6. So 6 and 3, it will be divided together to give the recoil velocity of the gun. So 6 and 3 will be divided, 3 by 6 will be 0.5. So this is given as the recoil velocity of the gun. Similarly, see this from your textbook, this is the numerical, that a 30 kg shell is flying at 48 meter per second. When it explodes, its one of the part of 18 kg stops while the remaining part flies on. Find the velocity of the later. So here the shell is exploded. We can say that it is flying at the velocity 48 meter per second, and its weight is 30 kg. Now after explosion, the motion of the first part will be that 18 kg and stops while the remaining part flies on. So the other part is moving it. Okay, so the second part will be of mass 12 kg, because we know that together the shell is of 30 kg. So first which one the exploded, the one part is of 18 kg, the remaining part will be of 12 kg. Now we are talking about the velocities. So velocity of the shell, that together the shell is given as 48 meter per second, but we know that the first part is having the velocity, it is not given, and the second part's velocity is given as, we have to find out the velocity. So we can say that the particle of the first part is moving with the velocity u, which is not taken as a 0 because it is moving, but the second part is exploded more fastly. So the velocity of the second part we have to find, but the velocity of the first will be 0. Okay, so here the 30 into because the conservation of momentum, the momentum of the before firing should be equals to the after firing or after explosion. So here the momentum is given as like this. So the value of V2 will be equals to 30 into 48 upon 12. 12 4s are 48. So 4 into 30 will be 120 meter per second. So I think you are familiar with this questions itself. A neutron having a mass 1.6 and 10 to the power minus 27 kg and moving at 10 to the power 8 meter per second. So these are the kg and the mass is given, that is the mass and the velocity is given, collides with a neutron at rest. So this is at the rest condition. Now which collision it is? Inelastic, right? Inelastic collision, what it is given by, that whenever they strike each other, they will move in the same velocity v, and they together the mass will be equals to m1 plus m2. And here the mass of neutron is given, that is 3.34. Find the speed of the combination. We know that the mass m1 u1 will be the sum of the m2 u2, and it will be equals to the sum of the masses of deuteron and the neutron together, but the velocity we have to find together what is the combination of the v. So it will be using the formula for the inelastic collision. Here you can see it as m1 u1 plus m2 u2 equals to m1 plus m2 v. Next question. A car of mass 1000 kg traveling at 32 meter per second dashes into a rear of a truck of mass 1000 kg moving in the same direction. Here also see what it is given, that the car is moving with velocity 32 meter per second and the mass of the car is 1000 kg, and the mass of the truck which is dashing it is of 8000 kg, and the velocity is given as 4 meter per second. After the collision, the car is bounced with the velocity of 8 meter. Now what is the velocity of the truck after that impact? We have to find it out. We know that before collision it will be m1 u1 plus m2 u2. After collision it will be given as m1 v1 plus m2 v2. So what is the velocity of the v2? That is the velocity with which the truck had after the collision. So it is given as v2 is equals to 72,000 upon 8,000. So this was the topic of the conservation of the linear momentum. So here we are going to learn about the rocket propulsion. This is also an application of the conservation of the linear momentum. This is a kind of application because we have seen now itself that the conservation of linear momentum's example, that the jet plane and the rocket. So what this rocket propulsion is, that it is moving with a conservation of the momentum. We can say that it is application of the conservation of the momentum. Now what the principle that is working in the rockets? We know that the principle of rocket propulsion depends on the two values, that is, one is Newton's third law of motion, that the force put by the second object on the first object will be equal to that of the force exerted by the first to the second and the second on the first, but they are both will be on the different direction. So F21 may be equals to minus F12. Okay, and the second one, it works on the principle of the law of conservation of momentum. So what the principle of rocket tells us, that the motion of a rocket is an application of the Newton's third law as well as the conservation of the linear momentum. We can say that whenever a rocket expels, it just release the gases, right? It releases the hot gases, and this is said to be the reaction of the force or action of a force, because whenever the rocket exerts gases in the downward direction, it will move upward, right? So these both are acting in the opposite direction. So the force by the gases will be in the downward direction, the force by the body will be in the upward direction. So both are moving in the different direction. So this is due to the conservation of linear momentum itself. So the hot gases acquire momentum in the backward direction, and the equal momentum of the body rocket will acquire in the forward direction. So we can say that here both the action is going, that is the conservation of linear momentum as well as that of the Newton's third law. So here in the textbook you can see this formulas, that how can we solve the questions, that whenever a body is there, that is rocket, let us consider at any time instant t that it is at the rest condition, then the velocity and the mass is given by m0 and v0. This be the velocity and the mass initial of that rocket at a time t equals to 0. That is expression for the momentum of the body will be given as m0 into v0, that is before moving a rocket, because now a rocket is at the rest condition, that is t equals to 0. Now at any instant t, now you have started the rocket to expel it. Now what it will do, it will release hot gases in the downward direction, which is given as vg. Let the velocity of the gases be vg, and the velocity with which the rocket is moving be v, because we have taken already v0, so it will be v now. And what is the mass of the rocket is, that is given by m. Okay, so here it is given as m. Now we can say that the mass m is now less than that of the mass of the initial mass. Why it is? Because whenever the rocket is in rest condition, now the gases not ejected by the rocket. So together the mass is there in the rocket. Now if it start ejecting, then the mass will be released, because some of the gases are releasing out, so the mass of the rocket will be decreasing. So the mass after time t will be equals to that of the less than the mass of the initial condition. So it is given by m, vg and v. And now after the time t plus dt, means after that ejection the rocket is already expelled out. Now what after the time t plus dt? We have seen at t equals to 0 and we have seen t is equals to t. Now we are taking t is equals to t plus dt. So these are the three conditions of the rockets, that is before expelling or before moving, and whenever it starts exerting the gases, and now it is moving in the upward direction. After movement it will be given that the mass will be of m plus dm. and the velocity will be given plus v plus dv. So the velocity is already increased and the gas velocity will be acting both in the downward direction, that is given by vg. Please see the books after reading this video. After seeing this video, you can see the book. It will be more easier to understand. Okay. So after small interval t, it is given by a decrease in the mass is given by dm. So it is by m plus dm, and decrease in velocity is given by v plus d. So there is some decrease in the velocity as well as the decrease in the velocity is increased but the mass is decreased. So decrease in the mass will be given by dm and increase in the velocity will be given by dv. So we have to find out the relationship between this. We know that the body, the conservation of momentum is working. So what the conservation of momentum tells us, that is m1 u1 plus m2 u2 should be equals to that of m1 v1 plus m2 v2. So using this condition, we know that before the time, that is time t0, at time t equals to 0, what was the mass and the velocity of the rocket? It is m and u. So it will be given by mu. What should be it is equals to, that is after decrease in the mass is given by m minus dm and increase in the velocity is given by v plus dv. So this is the momentum. Along with the momentum of the momentum of the gas. So what it is given by, that is m minus dm into v plus dv, and along with the gas, that is dm into vg, but vg is in the downward direction, so it is given by minus vg. Okay, so here the gases are escaping in the downward direction, so it is taken as a minus vg, and this mass and the velocity is given by the time t, that is moving with some mass and velocity. So this is the momentum. Now that we have taken a dm and dv together, these are two small values, right? If we are just using this product rule or the distributive rule, then what is the value? It will be m into v, it will be given as mv. Now again that m will be multiplied to dv also, it will be m dv. Now minus dm into v, again dm dv, and minus dm vg. So what will be the value of dv and dm? It will be too small, so m dv will be equals to that. The product term can be neglected. Okay, so on neglecting it, it can be given as m dv is equals to dm v plus vg. This is the only remaining part. Other are, this part is already deleted. So what is the value remaining? There is mv. Here also we are taking mv, so both are already cancelled. So what the value remaining here? m dv is equals to minus dm. Dm is taken as common. Okay, dm is taken as common. So the value is given by m dv is equals to dm v plus vg. So what does it mean? That the mass and the change in the velocity is equals to that of the gas along with the rocket's mass and velocity, right? So here the relation can be seen in the book also. Here the dm and dv is already cancelled out, so the remaining is this one, and how it can be written as m and dm, right? So with respect to rocket, we can write it as u is equals to minus of vg plus v, because both are acting in the opposite direction. So the velocity of the rocket will be equal to that of the negative of the velocity of the rocket and the burning gases together. So this is given by conservation of the linear momentum. Now if you are taking as m dv is equals to minus u dm, so from here the dv will be equals to minus u dm upon m, and now if we integrate it, then what the value will be? V is equals to, u will be of constant, it will come out minus u, and dm will be there but dm by m, but the integration of the 1 by m will be log m, and if you are taking it from mass m0 to m, then it will be log m0 minus m, and what it is given as u log, because m upon n, m minus n is given as m upon n, so m upon m0 is, this is the velocity for the rocket at any time t with mass m. Similarly, the thrust is also seen, that is the force exerted on the rocket. So what that it will be given by, that is force is equals to minus u dm by dt. This is the formula for the force. Okay, that is the thrust present on the rocket. So these are the formulas which are used in the topic, that is rocket propulsion. Here are the formulas you can see, that is acceleration is given by, what the acceleration is given by? Force is equals to mass into acceleration, so acceleration will be given by force upon mass. So this is the relation, and this is the upthrust on the rocket and the weight of the rocket, that is resultant force, because the upthrust that is moving the rocket in the upward direction, so the force acting on it is given by minus d u dm by dt, and the other one, the weight of the rocket, is acting in the downward direction, that is mg. So both together is written as u dm by dt is equals to, so u dm by dt minus mg, and the acceleration is given by u upon m0 t dm by dt, that is force upon mass is given by dm upon dt minus g, and the velocity is given by, we have already found out the value from the log, right? From there it is, and the burnout speed of the rocket is given as u0 plus u log m upon mr, that is the mass of the empty rocket. So here you can see the question that fuel is consumed at the rate of 100 kg per second in a rocket. So consumption of fuel is given as 100 kg meter per second. So this is the value of the velocity. The exhaust gases are ejected at the speed of 4.5 into 10 to the power 4 meter per second. So what is the value, that is what rate with which the fuel is consumed by the rocket? It is given as dm by dt, right? Dm by dt, that is kg meter per second. The kg per second, so it is upon mass upon time, so it is given by dm by dt is given as 100, and the velocity that with the gases are ejected is given by 4.5 into 10 to the power 4 meter per second, and we know that the upthrust, that is the force acting on the experienced by the rocket in the upward direction, is given by upthrust. So what is the value of the thrust force? That is F is equals to u dm by dt. Now what the u dm by dt is given as, u is was 4.5 into 10 to the power 4 meter per second, and the dm by dt was given by 100. So on multiplying both the values, we can get the force or the upthrust acting on the rocket. Second question, a rocket of the initial mass 6000 kg ejects a mass of at constant rate of 16 kg per second. So one is the mass of the rocket and the other one is the mass of the ejection of the gases, and with the speed it is given 11 km per second. It is the velocity of the rocket, and now we have to find out the acceleration, and we know what is the formula for the acceleration. It is given by u upon m0 minus t dm upon dt, and after the bracket it is given dm upon dt minus g, right? And this g is only taken when the exhausting gases are moving with some velocity in the downward direction. So here the neglect gravity, it is already written in the question that neglect gravity, so the minus g will be not taken in the formula. Here the m0 is given that at an instant t equals to 0, the initial mass is given 6000 kg, so u will be 11 km per second, and similarly t is given 1 minute, that is rocket a minute after the blast. After the blast, what is the acceleration it is asking? So after 1 minute, that is 1 minute is given, time is given 1 minute, we have to change it in seconds, so it will be 60 seconds, and dm by dt is given as 60 kg per second, that is ejecting mass at constant rate, right? Mass upon time, so it is 16 kg per second. So the value we have to put out and find out the value for the acceleration. Next question, the mass of a rocket is 500 kg. So mass is 500 kg, and the relative velocity gases, again dm by dt is given here, that is 250 meter per second, and the mass of the rocket is also given, that is 500 kg with respect to the rocket, and here the initial acceleration is also given by 20 meter per second square in the upward direction. So acceleration is already given, okay, and the next thing it is given that in the upward, determine the rate of the burning of the fuel. We have to find out dm by dt, okay, we have to find out the value of the dm by dt. Now if we have to find out the dm by dt, we can use the value of the force also, because we know that the acceleration is given by u upon m0 minus t dm by dt and dm by dt minus g. So here we can use the formula, but the velocity of t dm by dt is not taken here. So it is u0 upon m0 dm by dt minus g. The bracket, inside the bracket the value is changed. So we can write the initial acceleration as a 20 meter per second square, and the u is given as 250, and second thing 500 the mass of the rocket, and dm by dt, the rate of the change of the gases or the burning of the fuel, is given as 250 meter per second. So taken as the value, we have to find out the dm by dt, but 250 is given as the velocity u, m0 is given as 500, and acceleration is given as 20 meter per second square, and g is taken as 9.8. From here we have to find out the rate of burning of the fuel, that is dm by dt, okay. So the last question, which is given as the rocket is set for the vertical flight, rocket is already allowed to fly if the exhaust gas is 1200 meter per second. Now again the 1200 meter per second is given, that is the velocity of the rocket. How much gas must be ejected per second? Again dm by dt, we have to find out the value of the dm by dt. To overcome the weight of the rocket, to give the rocket an initial velocity upward direction, give the mass, and mass is given, okay, m is given 6000 k, that is the rocket mass is given. And what we have to find, that what thrust should be needed to overcome the weight of the rocket. What is the weight of the rocket? It will be given as mg. And we have to find out the thrust also. What is thrust? F is equals to u dm by dt. So what the thrust to overcome the weight of the rocket? So u dm by dt should be equals to that of the mg. So both are equal. So to overcome, what is the force? So it will be du dm by dt is equals to mg. And we know what the dm by dt's value will be, mg upon u. And we have already know the value of the u, that is 1200 meter per second. What is the value of m? That is 6000 kg, that is of rocket. And g's value is acceleration due to gravity, that is 9.8. So we have already found out the value of dm by dt. And for the acceleration, you can use a u upon m0 minus t dm by dt. And after the bracket is dm by dt minus g. So we just have to find out the value of the dm by dt again, because it is written. We have to find out the thrust needed to give the rocket an initial vertical upward acceleration. The acceleration is given 19.6, but we have to find out the value, that what will be the dm by dt. So from here we can use the value of the formula to take out the value. Okay. So nextly, what is the question? That if the maximum possible exhaust velocity of a rocket be 2 km per second. So already the given value is 2 km per second, u is given as, and calculate the ratio of the m0 upon m. So we have to find out the value log m0 upon m. We are having this value. So from there we can put the value of u and v, and we have to find out the ratio of the m0 upon m. But this log's value will be taken as the antilog when it reverses to the RHS side, then it is taken as antilog. And antilog's value will be taken by the antilog table. Here it is not given, and in some exams the antilog's value is also given in the bracket. Okay. So the last question, that the rocket motor consumes 100 kg of fuel per second, that is dm by dt is given, exhausting with a speed of 5 into 10 to the power 3 meter per second. Again u is given, because the rocket is moving with velocity, so it is v, so u. And what the force is exerted, so we have to again find out f, that is u dm by dt. So u is 5 into 10 to the power 3 meter per second, and dm by dt is given as 100 kg. So together it can be given as 5 into 10 to the power 5 Newton. And what the second question is, that what will be the velocity of the rocket at instant its mass is reduced 1 by 20th time. Initial mass and its initial velocity is given by 0. Again we have to find out the ratio of the m0 and m. Here the initial velocity is given as 0, so value of u will be 0, and here u log m0 upon m will be taken as 5 into 10 to the power 3 velocity of the rocket, that is u is given, and log m0 upon m. What is the ratio? It reduced to 1 by 20th of its initial mass. So m0 is the initial one and m is the total mass. So it is 1 by 20, then it will move upward, that is 20 will come. So log 20, it is given by 1.3. So on multiplying to these values, we can get 14.98 into 10 to the power 3 meter per second. This is the upthrust. So you can just see the topic in your book also, that what the rocket propulsion is, and what are the variable mass, and what is acceleration and the upthrust. 3 are the topics through which you have to go, and 3 formulas you can easily read. That what was the force, it is given by u dm by dt, and what was the resultant force along with the weight of the rocket, it will be u dm by dt minus mg. And we have seen the velocity also of the rocket after time t. It was given by v is equals to v0 plus u log m0 upon m, and dm by dt is the rate of change of the mass exerted by the exhausted gases at time t. And we have find the acceleration also, that is u upon m0 minus t dm by dt into dm by dt minus g. If gravity is neglected, then it is taken as dm by dt itself. If the gravity is taken under condition, that will be minus gt. Okay. So the last topic for your session is weight versus apparent weight. Now what is this apparent weight? If we have already, every one of us have traveled in the lift also. So we already seen that whenever we used to sit in or stand in a lift, then what happened to our mass? We think that whenever it moves upward direction, when the elevator starts or the lift move in the upward direction, we feel as that our mass is increasing. Right, we are just thinking that our mass is doubled, and we are taking our mass in the upward direction, like we are just taking it together. So mass is increasing when the lift is moving upward direction. So that is the weight along with the apparent weight, right? So the weight is taken as the apparent weight now, and we know that whenever the lift is moving downward direction, we feel that our weight is decreasing. Okay, so when we vertically downwards through the gravity, when we come to the gravity, we feel that our weight is 0 or our weight is decreasing. So that is the apparent weight. So we will see this through the example of the elevator or the lift. When we enter the elevator and press the button, it will taken as our normal weight, and our normal weight is taken as mg, and it always acts in the downward direction through the center of the towards the center of the gravity of the earth. So it is given as mg. Now when the switch is on and we have to move in the upward direction, when the elevator accelerates upwards, we feel that our body becomes more heavier, or we feel that our normal weight is gaining extra. So we are feeling that our weight is increasing. Now we can say that a slow stop at your flow, you feel slightly lighter at that of the normal weight, right? When we move upwards, then we moving upward with the elevator, then we feel that our weight is increasing, and as we switch off the lift, then we feel that our weight is now of the normal weight. And again when we come in the downward direction, then we feel that our apparent weight is again decreasing. So this is known as the apparent weight. So what this apparent weight is, we know that weight is a kind of force that is given by Newton itself, and it is equals to force is equals to mg. Same thing, force is equals to mg, we will be seeing in the last topic of your chapter. Okay, force is equals to mg. And here we can say that whenever we are moving downwards, then our weight is towards the center of the gravity. And what the center of gravity is also doing, it is also pulling us towards it. So our weight is towards the pull of the gravity only. So we feel that our weight is decreasing, and we are moving against the gravity, then we feel that our weight is increasing. So actual weight is increasing more than that of our normal weight. Okay, so force is acting in the upward direction due to the gravity will be equals to that of the Fn, that is apparent weight, and in the downward direction of a normal weight is always working, that is W is equals to mg or F is equals to mg. Okay. So it can be given as, whenever a body moving in the upward direction, it will be given that whatever the our force together, the weight, that is the apparent weight acting on us, and the gravity is acting in the downward direction, both are in the opposite direction. So what will the net force will be given as, both will be added together. Net force is the sum of the forces acting on the body, but both are in the acting opposite direction, so Fn minus Fg. And when we are talking about the apparent weight, when the body is moving or the lift is moving in the downward direction, then it is given as a net force plus mg, or together along with the gravity, along with the force experienced by the man due to the gravity. So here this is from your book, that what is the apparent weight is given as, we are taken a body that is in the standing in the weighing machine. You take as elevator or the lift or any machines also. Then the body is at the elevator, then your mass is always acting in the downward direction, that is the weight. It is given by the force F is equals to mg, or weight is equals to mg. Now then the R, where this R is given as the weight that is or the opposite force that is acting on us, or the weight that is offering the force but in the opposite direction. So this is the resistive force which is given as the R. So this is a reaction. Okay, because in the first law of motion we have said this, that Galileo told that every force exerted by the external agent is not only the force, but some opposing force is also acting on us, right? And that is given by R. So R can also be taken as the apparent weight in this condition, because our weight is feeling like it is decreasing and increasing than our normal weight, so it is taken as the apparent weight. So in the first condition, now the elevator is not moving, we are at the rest condition. So our weight is acting in the downward direction, that is mg, and the reaction, that is the apparent weight, R, is in the upward direction, right? Now it started moving upward. Now what will the value? Now when it move upward, the force and the weight will be acting in the upward direction, but our weight is always in the direction towards the gravity. So mg is in the downward direction, but our weight, apparent weight, is moving upward along with the acceleration of the elevator. So the external force cause is due to the elevator, so the acceleration of the elevator in the upward direction, but acceleration due to the gravity and the weight of our body are in the downward direction. So what I can write, that the force experienced by that body when that moving in the upward direction will be R plus mg, that is the net force, but mg is in the different direction, so it is taken as minus mg. So R minus mg is equals to m into a, that is force is equals to mass into acceleration. So from here we can write this apparent weight as R minus mg is equals to m into a, and R's value will be mg plus ma. And now when the lift moving downward direction, what it feels like, that mg is in the downward direction and r is in the upward direction, but the acceleration is also in the downward direction. Now what is acting upward? That is only the apparent weight. So r is now negative because acceleration and g both are in the positive direction. So the net force is in the downward direction. So net force is in the opposite direction, but our net weight is acting in the downward. As mg is taken as positive and the force is, that is mass into acceleration, will also be taken as positive, but our r, that is the apparent weight, that is only acting upward direction. That's why we feel that our weight is decreasing when we are vertically coming downward in the lift. We are feeling like that our weight is coming to be negligible, right? We feel that we are going to fly. So in that condition, the apparent weight is taken as negative, that is mg minus r. In the first condition, we have taken r minus mg because mg is in the downward direction and acceleration is in the upward direction. So it is given as r taken as negative, and mg minus r is equals to m into a. So from here, the apparent weight r is given as mg minus a. Now the third condition, when the lift is at the rest or in the uniform velocity, not upward direction, not in the downward direction. So as we have entered, we are waiting for the persons to enter into the lift, so we are in the rest condition. So what here, the weight will be in the acting in the downward direction and r will be acting in the upward direction. There is no acceleration acting on our body, no acceleration due to the external force, that is no acceleration is acting on our body due to the elevator. So the upward apparent weight and the downward mg weight, what the net force will be, it will be 0, m into a will be 0, acceleration is 0, so the force will also be 0, but the apparent weight that is acting on the upward direction r plus mg that is acting in downward direction, that is minus mg, will be equals to 0. So what we can write it as r plus minus mg equals to 0, that is r minus mg equals to 0, and if we take it in the right hand side, then r is equals to mg. So what is the apparent weight? That whenever the lift accelerates upwards, the apparent weight of the body, it feels to be like increasing with respect to that of the normal weight. So it is given as r m g plus a. mg was the normal weight, but along with mg, g, along with that the acceleration of the elevator is also coming, so g plus a. And when the acceleration is in the upward direction, it was moving now in the downward direction, so accelerating it downward direction. So lift is accelerating downward direction and our weight is also in the downward direction, so the apparent weight will be given as mg minus a. Now we are feeling that our weight is decreasing as respect to that of the normal weight. And the last one, that is r is equals to mg, because it is at the rest condition, there is no acceleration on the body, it is only the weight that is acting on our body, and the apparent weight is always in the opposite direction. So both are in the opposite direction, so it will be given as the balanced force, that is r is equals to mg. If the lift falls freely, that is under gravity only, so the apparent weight will be 0. Okay, apparent weight of the man must be 0 because both the man and the lift are moving in the downward direction and acceleration due to gravity is also in the direction. So there is no force of action and reaction will be acting on our body, and we will feel that we are weightlessness. Our weight will be falling under the gravity. So weight will be feeling that it as a 0. Okay. So these are the formulas which we have used in this topic, that is apparent weight. And here are the numericals related to the apparent weight. You can see many more the numericals in your book also. I have got the one, that is lift of mass 2000 kg supported by thick steel ropes. We know that steel ropes are only used for the lift in the elevators. That is given by the mass 2000 kg and the maximum upward lift. Now it is moving upward direction. Okay, now we will feel that our body is increasing, that our weight is increasing along with the lift moving upward direction. So lift is moving with upward with an acceleration of 1.2 meter per second square. So from here we can find out the tension, that is the weight applying a force on that rope, that is the tension. We will be talking more about the tension in the next topics. So the force is given as m into a. We have talked that m into a. So that m into a was given by 2000 into a, but it is moving in the upward direction. So the value of the apparent weight was mg plus a. So plus a will be the acceleration along with the gravitational acceleration. 9.8 plus 1.2, it was taken as 10. Okay, so it is taken as 11, and 11 into 2 it will be 22, and 22 into 1000 it will be 22,000 Newton. So the tension on the rope or the apparent weight that is acting on the ropes of the lift is taken as 22,000 Newton. And what's the next question is, what should be the minimum diameter of the rope? What the diameter should be? We know that whatever the stress on the rope is given by force per unit area. We have already learned in the 9th and 10th also that the force acting on any body, it is taken as under the pressure of the area. It is said to be the stress. Then what is stress or the pressure? Both are the same words only. stress or the pressure is equal to the force experienced per unit area. So tension or force is given by 22,000. And what was the area? It is taken as a cylindrical shape also, and it can be taken in the circle shape also, because rope from the upward direction is seen as a round shape. So it is taken as the pi r square. If we take it a diameter, because we have to find a diameter, then d will be equal to d by 2. R is taken as d by 2, right? So on squaring that, it will become d by 4. So d square by 4, and 4 will move upwards. So 4t by pi d square. From here, the force tension we have already find out 22,000. So we can put the value of tension into 4, and pi will be 22 by 7, and we have to find out the value of the d square. And question, it is given that breaking the stress for the rope is 2.8 into 10 to the power 8 Newton meter per square. So it is given as 2.8 into 10 to the power 4. From here we can find the value of the diameter of the rope through or up to which that the breaking stress can limit. Okay. So these are the topics which we have learned in this session. That is, 1, the conservation of the linear momentum. 2nd, the application of the conservation of linear momentum in rocket propulsion. And the last one was apparent weight. Okay. So this was the topic of the loss of the motion, and the last topic, there is a tension and the mass of weight of the body. So that we will be studying in the next session. Okay. Thank you, class.